Chalk Talk is brought to you by Isolite, the emergency lighting experts. Stay educated, my friends.
Hello, everyone, and welcome to our July Chalk Talk. I'm your host, the Eastern Regional Manager, Matt Bird, along with our Western Regional Manager, Greg Keel. Introducing Evan Ackman, who is our Director of Product Development, who will be running the call today. And today's focus is going to be on wet and hazardous location ratings and really what it all means. So thank you all for taking the time to be on here. Our promise is to keep this to 15 minutes. So in respecting that time, I'd like to turn it over to Evan. Evan, please go ahead.
Great. Thanks, Matt, and thank you all for joining. As Matt said, our goal today is to talk about wet and hazardous locations, and we're going to do that in three parts. We're going to talk about terminology and background. What do IP ratings mean? Where do they come from? How does that relate to NEMA ratings that enclosures carry? Obviously, NEMA does a little bit more than the IP ratings, covering not only water resistance, but also hazardous locations. And then we'll also touch on cold weather and internal heaters, what they're doing for you, when they might get utilized, and how to specify a product that utilizes them. We'll then kick over to talking about particular locations and installation types, and then what's required for those installation types. We have a good matrix of installation type, and then what features of exit signs or emergency lights you might mean. And then at the end, we'll talk about products that go into these applications in particular. And then we'll also talk about the sales tools that we're going to provide to you guys as follow-up to this, this webinar. So let's get right into it. The first thing that I think is confusing about wet location and cold weather location and hazardous location are all the different ratings that you might see that relate to it. And the first of which is the IP ratings. And so the IP standard is something that came from the IEC in Europe. IEC is International Electrotechnical Commission. So it's a European thing by its nature, but it was actually later adopted and expanded by ISO for use globally. And the IP rating system is it's actually pretty nice. It's very algorithmic and simple. And so what you're going to see is the letters IP and then two numbers following it. And then the numbers actually correspond to very particular types of intrusion protection. So the first number that's there relates to solid intrusion protection, and those numbers are 1 through 6, and it kind of varies from, you know, like no protection if the number is like just missing or an X is there. But in terms of the ingress protections, it'll protect against things like big, like your hand, all the way down to very small, like dust. So as the numbers get larger, the device is more protected from those sources of solid intrusion. The second number is what we would actually care about when we're talking about wet location products. So they also have numbers a little bit larger scale, so from 1 to 8. And again, it varies from no protection or very basic protection of, you know, some incidental splashing of the product is okay, all the way down to 8, which is really means that you can submerge the product at like 3 feet or something, and it will still survive. And these are nice because as the numbers get larger, you can infer that there is more protection. The numbers that you're actually likely to see, particularly as we talk about wet location products, is IP66. So this first 6 indicates that the product is sealed against dust, and the second 6 means that it is protected against direct water spray. And that water spray is really from any direction. So every wet location product that we have is going to have an IP66 rating or above. Because the numbers are nice and they go, the bigger they get, the more protected they are. There are some instances where we might be able to meet IP67 as well. There's also this thing that's floating in the nomenclature of our products that is damp location. And you can get damp location on a number of different products. You'll notice that they don't traditionally have an IP rating listed next to it. That's because damp location is not necessarily the same strictness as wet location rating. UL basically says if you're going to claim damp location, you have to be in a situation where you're protected from weather, you don't have to expect saturation from water, really you're going to be under a canopy in a basement, a place where there might be condensing moisture or a moist environment, but not subject to actual weather. So the rating that most of those products would be able to carry would be IP41, which is protected against small intrusions and protected against falling water droplets. Sort of the thinking there is that if there is condensing water on there, if it falls straight down, that would be okay, but definitely not the level of protection that you'd get on an IP66 type product where water could be coming at it from any direction. So those are the ratings you're likely to see from an IP rating perspective. But what is this NEMA rating thing? These are like IP ratings, but they're very US specific. And there are equivalents to the IP system, which we'll talk about on the next page. The real problem with NEMA ratings is they're a little bit more prescriptive or a little bit less algorithmic than the IP ratings. So the numbers getting larger doesn't necessarily mean that the product is more protected. There are some local minima and maxima where if you increase the number of the NEMA rating, you're actually getting less protection against intrusions. There's also this additional thing where there are suffixes to NEMA ratings. So they can have additional things, like if you put an X at the end of the NEMA enclosure number, that means that it's corrosion resistant as well. There are certain suffixes for allowing of buildup of ice. There's a lot more sort of, you just have to know what the rating is. You can't guess just based off of the number. NEMA also covers hazardous location enclosures as well, which we're going to talk about in 2 slides specifically. But here's the equivalency table. And again, I've highlighted the ones that we're actually going to care about as they relate to wet location ratings. Where I said that IP66 is the IP rating we'd care about, you can see that that generally corresponds to NEMA 4 or 4X enclosures. And if you look at our spec sheets for products that have wet location ratings, we'll actually list both IP and NEMA. And because of that strangeness in that, higher NEMA numbers don't necessarily mean more protected, if it has a NEMA 4 or a 4X rating, it's also going to have a NEMA 12 and 13 rating as well. And you'll see that represented in the spec sheets. And we can do that because of the fact that the NEMA ratings are a little bit goofy. But you can actually see here that, for example, NEMA 5, it's a bigger number than 4. That might infer more protection, but it actually doesn't. The equivalent is IP 63 or 53, excuse me. So a little bit less protected. And then you can see 12 and 13 are also less protected than that NEMA rating would imply. Sitting in the middle of this table, though, are NEMA 7, 8, 9, and 10, which are really the hazardous location enclosures. And that's where I think the industry has a little bit of confusion. And the first thing that I think is confusing, or I think confuses people, is the nomenclature. So we're pretty particular in calling these hazardous location signs or emergency lights. I think colloquially people call them explosion proof, but that's not really correct. What these signs or lights are capable of doing is being installed into atmospheres where there is explosive gas, dust, or fibers, and the sign or emergency light won't cause an explosion. So when you look at these different hazardous locations, you're going to see classifications, divisions, groups, and temperature codes. The class indicates what type of material is present in the atmosphere that could be explosive. So class 1 is explosive gas, class 2 is dust, and then class 3 would be fibers. There's this division thing which indicates the likelihood of the presence of the explosive material. Div 1 means it's there in normal operation. Div 2 means it's only present in abnormal conditions. You can think of that in like the class 1 case as, explosive gas being present in normal operation is something like a paint booth. If you're spraying paint around, that's a normal operation and it's putting that gas into the air that could be explosive. Class or Div 2, you might consider something like a natural gas refinery where there is explosive natural gas present, but hopefully it's kept in pipes the entire time. It would be an abnormal condition if it were outside of those pipes. There's some additional stuff that you're going to see on spec sheets, like what groups the products cover. The groups just indicate the particular type of explosive. So when talking about class 1 explosive gas type products, you're going to see ratings for acetylene, hydrogen, ethylene, propane, methane, and then so on and so forth. The last thing that you'll see is a temperature code, T1, T2, T2B, T3. I think it goes up to like T6C or something like that. That just indicates the the ignition temperature of the gases that you're expecting within that group. So again, the idea here is that the signs aren't explosion proof per se. They're capable of going into explosive atmospheres, and they will not cause an issue. That's why you do see exit signs and emergency lights that have like polycarbonate shields on them. Yeah, of course that won't survive an explosion, but it's gasketed and potted in such a way that it won't cause an explosion in those types of environments. Cold weather is kind of an outlier. There's no NEMA or IP standard that really governs these devices. Really, the situation is if you need a lower temperature rating, so something that goes below the traditional 32 degrees Fahrenheit, that's when you would furnish a product with an internal heater to drop that low end of the temperature spectrum down by 30 or 40 degrees. It's important if you're doing applications that are maybe in refrigerators, or if you're doing outdoor products that are in places that have cold weather. So like where we're located here in Philadelphia, if you're in California, maybe you don't need the cold weather rating. So because of that, you'll actually see a pretty high crossover between products that carry wet location ratings and products that have internal heaters. There's high overlap, although it's not perfect. A lot more of our emergency lights can have internal heaters than have wet location ratings, but there is a kind of a high crossover. The other thing to bear in mind here is the cold weather and internal heaters obviously cover the low end of the temperature spectrum, but what do you do if you need to go to higher temperature areas, like a refinery or something that's dealing with like molten metals or something? High temperature rated products are few and far between, and really the limitation there is on the battery side. If you need a high temperature rated product, above the 100 degrees Fahrenheit or whatever the rating of a traditional sign or emergency light would be, you really only have two options. On the exit sign side, you're going to have to go with the self-luminous sign. There's no battery in those devices and there's no wiring associated with it. So they actually have a pretty high top end of temperature ratings. If you're trying to get an emergency light into those applications, you're really going to have to go with the standard architectural light that's there with an inverter that's placed out of the way. There's really not a lot of emergency lights that are going to have really high temperature ratings just because of the batteries are the thing that goes bad when the temperatures get really high. In terms of the decoder ring of types of installations compared to the types of protections that you would need, you don't have to scribble to write this down. We'll certainly send out this slide deck as a follow-up. In particular, there's a couple things I want to draw your attention to. You can see the representation of difference between wet location and damp location here when we talk about parking garages. So on the parking garage interior where it's shielded from weather, you probably really only need a damp location rating because it's not going to rain on it. Whereas if it's near the exterior or it's not totally protected from the elements, that's when you'd have to shift gears and go to a wet location. And because those are both technically outdoor products, they're both probably going to need a cold weather rating unless you're in Florida or California or someplace that stays pretty warm all year round. The other thing to keep in mind here is this is not exhaustive, but you can see down here we have the hazardous location products, grain mills, paint booths, oil refineries, things like factories that have explosive materials in them. Those are where you're going to need these hazardous location products. And you may, depending on the type of factory, also need some additional protections. Cold weather isn't common, but wet location would be pretty common depending on how the processing is working in the plant. This list of products is by no means exhaustive, but I did want to call out a few things. So in the damp location column, I've listed our ELT and our bug, which are very architectural products. A lot of the product line can carry a damp location rating just because it's a lot simpler to list a product for damp locations than it is for wet locations. So most of our architectural signs and lights can carry the damp location rating through an option in the options section of the ordering nomenclature. Wet location is a little bit more specific. We've listed our Max and HL as the typical products that would get deployed in those applications, but we have a lot more. So like RWL, HLX, HZE, and all their equivalent combos are wet location exit signs. And then for the emergency lights, obviously the HL, as you see here, HZN, HZZ, HCl. Those are all capable of going in wet locations. Hazardous locations are the most difficult products to engineer. So from an exit sign perspective, you're really only going to get the EXP and the HZE capable of going into hazardous locations. And then from the emergency light side, it's HZL and HZZ. The other thing that can go in both wet and hazardous locations that bears mentioning is all of our tritium self-luminous exit signs. So because there's no electricity there, because there's no battery in those, they're capable of going in wet location and hazardous locations. And then photoluminescent has the same characteristic. Because it's just a photoluminescent impregnated piece of plastic, it can go in wet locations and hazardous locations too. And in addition to that, already up on the webpage, we have our spec sheets that are pretty good at detailing exactly what protection classifications, both from an IP standard and a NEMA standard, the products meet. We have drawings that show how they're gasketed. With that said, if you have any requests, if you need more information on this or any topic, my name is Evan Ackman. I'm our Director of Product Development. Greg and Matt are on the line right now. They're certainly available to answer questions. If you want to talk, please don't hesitate to reach out to us. We're happy to help. That's what we're here for. Otherwise, thank you for joining our webinar. We kept it to 16 minutes, almost made it. Thank you so much for your time.